I think we're good. Yeah? All right, we're going to get started and try to stay on time, which is not easy for me since I'm from New York. We're late for everything, so someone yell at me. Ivan's here, so he'll keep me in check. Anyway, welcome everyone to NIBS Building Innovation breakout session number 3. Today we're going to discuss a case study that's focused on integrated panelized building systems and do a deep dive into the CertainTeed Saint-Gobain ONE Precision Assemblies platform, which is very exciting. We're delighted to be joined by several senior members of the Saint-Gobain Offsite Solutions team. Dennis Michaud is Managing Director of Offsite Solutions at CertainTeed Saint-Gobain, responsible for the development and commercialization of new solutions and services for greater productivity and sustainability in the building industry. Will Lentley is an R&D manager of new product development for CertainTeed, where he focuses on launching innovative products for the offsite construction industry and is the technical lead for the development of the ONE Precision Assemblies platform. And Matthew Campion, last but not least, is the Director of Government Affairs at Saint-Gobain North America. Matt leads state and federal government engagement strategy across the company's North American operations. Prior to Saint-Gobain, he led the government affairs programs at the Home Depot and the Federal Reserve System, which must have been a lot of fun. My name is Tyler Schmetterer, the managing partner of ModX, along with my partners Ivan Rupnik and Ryan Smith. We are a research-based advisory group and international knowledge exchange network focused on supporting industrialized construction. Over the past 10 plus years or so, we've supported industry and government at federal, state, and local levels to transform towards functional industrialized housing delivery. In partnership with NIBS, ModX has completed several multi-year research grants with the U.S. federal government, primarily through the U.S. Department of Housing and Urban Development, otherwise known as HUD, including those pictured here. There are others as well. And we have recently launched with NIBS a Housing Innovation System Certification Pilot Standard to streamline project approvals that my partner Ivan presented on yesterday. For historical context, the U.S. is by far the largest construction market in the developed world and also the least industrialized, in spite of roots dating back over 100 years. This NAHB chart represents the total production of volumetric, modular, and panelized housing completed in the U.S. over the last 3 decades. It is not a pretty picture. During this period, total volume peaked at around 80,000 units in the early 2000s. December 2007 was the start of the Great Recession, which lasted about 18 months until June of 2009. This historic macroeconomic event had a major impact on the U.S. offsite industry, decimating annual impact of the U.S. offsite industry, and resulted in the closure of a substantial percentage of offsite manufacturers. Since that time, the industry has not recovered to previous annual output and has rebased just shy of 30,000 units, or so about 2/3 of the peak level, with slightly greater than half of that production in some form of panelization. As a general overview, in offsite construction, there is a spectrum of enhancement. On the least enhanced side, the left side there's industrialized stick-built construction, and on the most enhanced side, the right side, you have 100% complete factory manufactured HUD homes with various levels of enhancement in between, including open, closed, and volumetric. The line of inspectability, the red dashed line there, differentiates site-based versus factory-based inspections, which remain a significant challenge across the country with over 30,000 independent code jurisdictions. The important distinction is whether factory-built components are enclosed or open. before it leaves the factory. Enclosed subassemblies are often inspected in the factory before being assembled on site, whereas open structural components can be inspected on site, which is a much easier process. This map, produced by our friends at ICC and TA, which we often refer to as the Wild West, outlines the progress and continued challenges associated with building code, regulatory barriers to offsite evolution. Each state has a unique way in which it addresses offsite construction. This makes it very challenging, to say the least, for offsite methods to compete head-to-head with traditional construction, since each jurisdiction needs to be educated and socialized to the process while also concurrently adhering to local and state building code. Offsite construction and associated manufacturing are typically organized into three categories based on the degree of pre-assembly on the x-axis and the degree of enhancement on the y-axis. The general categories are 1D kit of parts, 2D panelized, and 3D volumetric. Panelized systems are made up of two-dimensional components, sometimes referred to as flat pack systems, and they vary widely from open panel structural components when only the primary structure is completed in the factory, to enclosed panels where the structure, insulation, interior sheathing, exterior finishes, and other systems are fabricated offsite. Volumetric modular consists of three-dimensional building sections completed in a factory. Housing projects can utilize different degrees of pre-assembly and enhancement methods to mix and match. By structural material and architecture, the main families or panels include timber stud frame panels, CLT panels, nail laminated, dowel laminated panels, light gauge steel, structural insulated panels or SIPs, precast concrete, aerated concrete, hybrid panels. There's a lot of panels out there, folks. By panel role, there are three main element types. You have your floor cassette, your wall cassette, and your roof or ceiling cassette. An integrated system will often produce all three on the same factory line. 2D panels can be open structural elements or enclosed, like I said, with insulation and linings. The images pictured here on the left are open wood frame panels that are flat packed on a carrier and ready for transport. This is the most common, the most cost-effective way of offsite production. Closed panels on the upper right are coming off an assembly line fully enhanced with windows, doors, insulation, siding, railings, interior finishes, etc. The image on the lower right is a 3D volumetric module that is being craned into place and set on a precast concrete foundation. With a supportive regulatory framework, deep market awareness, and acceptance, the offsite industry across Europe is largely comprised of closed panel systems. Scandinavia is at the top of the range by far, with countries like Sweden and Norway currently at an astounding 80 to 85% closed panel market share. Austria and Germany currently occupy 25 to 35% closed panel market share. And for an additional point of reference, Japan, their overall prefabricated housing market represents 13-15% market share for the whole market, with about 60% of that share being closed panel construction. The relatively recent success of the German market definitely provides key lessons for us as a nation. One of the many things we do at ModX is facilitate in-country research, tours, and knowledge exchange events around the world to learn more about highly developed panelized building systems. This particular exchange took place in Central Europe and covered areas of Germany, Austria, Northern Italy, and Switzerland. It was an excellent trip for all the reasons. The German offsite single-family industry is dominated by closed panel systems, representing 1 out of every 4 housing starts, which is an astounding level of penetration. These are some of the companies that we visited during our exchange: Haas, Balfritz, and Weberhaus. Typical high-end single-family and multifamily housing products that all offer different varying levels of product in a highly automated manufacturing facility. These closed panels are efficiently manufactured, highly enhanced, and offered at various levels of interior and exterior finishes and energy performance levels. This is one factory production line producing this myriad of different panels for different projects with different specs seamlessly, highly enhanced, highly cost effective. These closed panel systems are, like I said, highly industrialized and vertically integrated from the manufacturing process through site assembly and finish. It is a sight to behold, start to finish. So given that all that we've collectively learned over the many decades of international research of highly developed off-site markets and the accelerating housing crisis across our country, the operable question becomes, what does the future hold for integrated panelized building systems in the United States? And how can these systems help increase high-quality national housing supply at scale today? Let us turn to the CertainTeed Offsite Solutions team to learn more about their innovative One Precision Assemblies housing solution.
All right. Thank you, Tyler, and good morning, everybody. I just want to clear one thing up before we get started. You can say Saint-Gobain however naturally comes to you. I know many of you looked at it and said, oh dear, I'm just going to call it like the company or CertainTeed or whatever other word. It can be Saint-Gobain, Saint-Gobain, whatever works best for you. So, yeah, you're welcome. So, as I said, I'm Matt Campion. I am Director of Government Affairs at Saint-Gobain, where I support Dennis and Will and the team on a number of initiatives that we have going, one of which I'm really excited about. You're going to hear a ton more from the actual experts today. But I just want to give you a brief background on this mysterious French company so you can kind of understand exactly why we're playing in this space, what we're all about, where we're passionate, and we are passionate about a lot of things. So our goal is to become the worldwide leader in light and sustainable construction. And as you can see here, we are the leader in a number of markets in this space. But here locally in the US, we have a significant footprint that has been growing year on and year out. And it started really around the traditional building materials, think gypsum, insulation, siding, roofing, but we've really grown that to look at a range of systems thinking. And in a lot of ways, the interoperability between those core building materials and other R&D driven products that we've put together around envelope performance, and the like. So we have over 18,000 employees here in the US. We do about $11 billion in sales in this country, $55 billion globally. We have 160 facilities in 30 of the 50 states, which we're incredibly excited about, and a very significant and growing footprint in both Canada and the US. And I just want to pause on this slide to underscore that really this looks like a huge smattering of companies and various product lines, but at the corporate level, we are thinking every day about how to, connect all these products and build the best solutions for the home. And in my role, looking at the policy world, as many of you and much of the last day and a half have covered, that is what policymakers are looking for at the core, I think. At the end of the day, they are looking for options that not only present the most affordable, available, quick, ready-to-market solutions, but they're also looking for things like this, where, if we're going to build new construction, if we're going to look at opportunities for where, those high-performance products can really best fit into the marketplace, where are there providers who can provide insight into how those products all work together? And this is our core, and we're very excited about that. So, these, on the next slide here, are the trends that drive our business and yours. And to talk about a couple of them in specificity, when it comes to energy efficient renovation. This is the area where I think our company has, shined over the last couple of years, in particular with respect to systems thinking and really putting together programs that capitalize on the energy crisis that I think many markets have, especially in the US. The resource scarcity and driving circularity is at our core as well. A number of our plants recycle the same materials to produce new gypsum, for example, or we crush glass to make asphalt, and we do a range of other sort of circular economy type things that we believe at our core are the future of the sustainable housing and resilient market in the United States. And then middle-class aspiration for quality buildings. This is something that I think certainly my colleagues are going to talk to you about, because I think there's a real policy opportunity around modular and offsite and how that might be a solution both for the affordable housing market but also for the missing middle. When I meet with lawmakers and staff from offices around the country, I hear a lot about both sort of subsets of the population. The need for more affordable housing, but then also the need for solutions for those who might not fit into the low and moderate income space, but need some sort of option for a future energy efficient home. And I think that's where we end up talking a lot about one precision assemblies and modular and offsite. And then lastly, this is the solutions concept that I'm talking about, but it's really, as much as it's driven by our R&D, and Dennis and Will talk about that, it's also driven by what our customers need. And I include, policymakers in our customer base as well. They're looking at not only, how does roofing work with certain building envelope and moisture barrier types, but also, is there an opportunity out there to be rethinking how these systems fit together? And so I can think of no sort of better way to embody how we've been thinking about this over the last 10 to 15 years than our One Precision Assemblies platform, which I'm going to turn it over to Dennis now to touch on. Yes.
Well, I think my colleagues gave me one slide, which is smart because I can talk a lot. How I wanted to introduce One Precision Assemblies is to speak about why Saint-Gobain as a global company, which one? I'll stand here. All right. Why Saint-Gobain as a global company has been focused on offsite construction for many decades. A lot of the reasons that Tyler mentioned earlier, that we see this a lot more outside of the US, but why we're also so bullish and optimistic and feel it imperative that we get involved in North America in the growth of offsite construction. So these are just some figures in terms of what we've seen as the growth of offsite. This is globally. Various different types of offsite. Tyler mentioned some of these other examples that weren't mentioned: bathroom pods, like cage steel systems, precast concrete. And then on the left is where we are playing in offsite, either as a supplier to manufacturers of offsite components, panels, modules, etc., or as an offsite manufacturer, provider of offsite components ourselves. But why are we doing this? There's really three reasons. The first is that the labor challenge in construction, which obviously exists very much in the US, but it's not just in the US, is it's existential for us as well, right? As a building materials supplier, there's no one to install our materials. A, there's not going to be any construction, and B, we're going to have a hard time growing. We see the challenge as not being one of how do we build with less people. It's more about how do we build with the people that we have who want to build, and how do we attract more people into the industry. None of my kids want to be in construction. I think I was maybe the last generation whose dad was in construction, and I said, "Oh, this is what I want to do." And he said, "No, go to college. Don't be in this crappy industry." And so that's what I did, and then I came into the industry. But when we look at hiring people into the offsite ecosystem, we see young people saying, "Oh, cool! I get to use new software systems. I get to use robotics. I get to maybe it's the installation of panels and modules on site. I get to actually be part of an efficient process that is safer, that is more comfortable. I'm not working in the cold, and I actually get to feel as though I'm part of productively building housing or productively building buildings. Whereas candidly, spent a lot of time on the job site. When you're there, you don't feel like you're part of something that's very efficient in the traditional way of building. And it can be very frustrating. And I know it's extremely frustrating for young people who are thinking about getting into this industry. So the second reason that offsite is critical for us is that you can't really have innovation if, in order to bring out something new into the industry, you need to go and train tens of thousands of different very small companies and crews in how to use that new innovation. But for us, it's just not possible. There's a limit to what new we can bring to the market if we have no way of training all of the different people that are core to actually using and installing those products. Whereas in an offsite scenario, we can, there are 75, 100 different factories in the US that we can go to, train the entire team, do a train-the-trainer type program, and actually bring more innovation into the industry through that, through that consolidation of the workforce. And the last area is that we know resilience, both energy resilience and climate resilience, is fundamental to our industry. Honestly, materials play at best a 50% role in making a house last longer, be more weather resistant, be more durable in energy and lower energy use. At least 50% of the performance of a building comes from the installation quality and the precision of the installation. And you just don't have that quality control in a traditional setting. And so we look at ourselves and say, well, there's not much more we can do to improve unless we help improve how the materials are installed, not just the materials themselves. And with that, I'll hand it off to Will to speak to one of the ways we're doing that.
Thanks, Dennis. So again, my name is Will. I am a R&D manager with CertainTeed Saint-Gobain. I wasn't always a manager helping people do their work. I started as a building scientist, joining Saint-Gobain about almost 9 years ago, Dennis. And time flies. So Dennis and I have been working together on the development of One Precision Assemblies since I started the company. Sorry. I was the technical lead developing the system. So unfortunately, Dennis had a couple slides. I have a lot of slides. So we're going to go through them relatively quickly. But this is what I have been working on for the second half of my career, right? So I'm very passionate about it, and I hope, hopefully I don't go too far. These guys will yell at me if I'm talking too much, right? But so what is One Precision Assemblies? You've heard us talk about it a lot, right? It is a insulated and weather-tight system for walls, roofs, and floor panels. So we build panels in a factory that live kind of in this liminal space between an open panel and closed panel, right? And we'll talk about that more in a little bit. But we are enhancing these panels, taking plans from builders, designing those buildings digitally, panelizing them, building the panels in the factory, getting them manufactured, insulated, airtight, windows installed, ready to go, delivering them to the job sites, doing the raisings, and then ultimately validating those installations to improve performance, either by providing performance metrics for HERS ratings or blower doors, whatever it may be. Ultimately, it's one solution for 4 trades. We've got rough carpentry, all the framing happens in the factory, insulation and air sealing occurs there, the windows, and then ultimately you get weather-tight panels that turn into weather-tight envelopes. Right? So it was launched in 2023. As the result of 7 years of market research and R&D that Dennis and I have done a lot of those things in that time to address the largest challenges faced by home builders. So labor shortages is obviously a significant issue, schedule delays, warranty risks. It's very confusing who to point to when there's a warranty issue when you've combined materials from lots of different manufacturers. There's no one person to point to. And ultimately, Dennis mentioned quality and compliance, right? How do we streamline those things? And I think the work that we've done has addressed many of those things. So there's one fixed cost. You get a fixed cost when you request a quote from us. You get one cost for all your framing, windows and doors, installation, weatherproofing, what I talked about. Ultimately, we can raise a home in about a week. So you're from foundation to a raised envelope in 1 week, ready for MEP and drywall and roofing, and all that stuff. There's one warranty. Like I said, there's one person to point to when things go wrong, and don't worry, you will point at us when they go wrong. As it says, there's one throughout, as we say. So just a couple cool photos, I think, of in-factory manufacturing. Panels can get manufactured for a job in about a week, and they can get raised in about a week. So you'd think we'd be just building a house every 2 weeks, but there's a lot of other processes, engineering, and working with local jurisdictions to make that happen that tends to extend the process. But speaking of the process, the development timeline. This was a multi-year strategic partnership from 2018 through 2022 with the pandemic in between, so it took a little bit longer than maybe I would have liked. But we worked with a company called Unity Homes, which was a subsidiary of Bensonwood. They're up in New Hampshire. They're a panelized prefab manufacturer. Fantastic team. If you don't know the Bensonwood folks, you should look them up. A lot of the photos you see throughout this presentation, they were done in conjunction with them. They deserve a ton of credit there. We kicked off in June of 2018, and that's a long time ago, thinking about how are we going to do this, what kind of areas did we want to innovate in, and ultimately had some early concepts by the end of 2018. We did our first in-factory trials in 2019, and ultimately have decided on our assemblies, what we were going to offer, how we were going to build them, and to focus on some pilot homes in February of 2020. That's a rather ominous month and year. So you can see we started large-scale testing, or completed it in June of 2021. So there's a little bit of a gap there, probably what that is. Our first home was raised in 2022 and in January, and then our second home was in July of 2022. So and ultimately we publicly launched in 2023. So what did we do during that whole process? That's a lot of time, right, to spend thinking about a system and working on it, right? My background is in fluid dynamics, mechanical engineering, and building science. I actually came from the nuclear industry. I used to model reactors during accident scenarios, and then I started modeling houses. You might be surprised that houses are actually more complicated than nuclear reactors. I wouldn't believe that. So, nerdy dude at a building science conference, right? I was very interested in starting at the numerical modeling level, right? Leveraging numerical modeling, specifically the software we're using in this instance is Woofy, doing heat transfer and moisture transport through assemblies, understanding the various climate zones that we're working with. The system is currently launched on the East Coast, everywhere east of the Mississippi. So imagine having to design assemblies that you know will work for every climate zone that we may need to expand into the future, and do it in a way that we're not creating a liability nightmare if something goes wrong, right? Like, it's a big deal. So we would do numerical simulations and check for moisture at sheathing and at interior locations, making sure that there's going to be good indoor air quality, and these buildings are going to last a long time, right? I really hate when people talk about the 50-year life of a building. I think that's insane. I mean, my house is over 110 years old, and I hope it is there for much longer too, right? But because CertainTeed is offering all the materials as well as ultimately the full panels, we engineer the whole assembly design to ensure the predictable performance. We have to control every layer of the assembly and understand its performance and what it's offering to the envelope, right? So how are we going to manage air? How are we going to manage heat? How are we going to keep out bulk water? Because if you don't keep out bulk water, you might as well not worry about anything else. And ultimately, a real killer of buildings is managing vapor and preventing mold and mildew growth, and ultimately, leading to rot and sheathing. So just a cool exploded view of what an assembly ends up looking like, and on the other side of the slide is the different layers and how they contribute to those things. I could talk about this for hours, so I'd love to chat after, but I'd be happy to talk about it. But frankly, numerical modeling is great. I think it's very useful, but it doesn't give you assurance. And there's certain things that you can miss when you're modeling in 1D that you miss in 2D, or if you're modeling 2D, you miss in 3D. So we ultimately wanted to prove the performance through embedding sensors in homes. So in each of those first two homes that I mentioned, we embedded 50 plus sensors in them to measure key performance indicators. We wanted to validate the design. We wanted to enable accurate pre-build performance estimates. Did what we do in the simulations match what we're seeing in real life? And we want to ultimately inform future design improvements, right? What we started with in 2023 is not what we sell today, and what we sell today won't be what we sell in another 2 years, right? We're always evolving. So what we did was we combined temperature, relative humidity, energy use data, measured indoor air quality, weather data. That all gets uploaded to the cloud and then ultimately goes through our custom data processing Python software that we've written to track the performance of these. Here you can see some installation of sensors embedded in walls and roofs. We used off-the-shelf sensors. These aren't anything special. You can buy them. You know, I could show you how to do this yourself if you want. I'd be happy to talk about it. We also needed to make sure that the materials that CertainTeed sells today, things like insulation, for example, can be adapted to an in-factory environment. Europe is much more advanced in developing equipment that installs materials, but dense packed fiberglass, for example, is not something that was traditionally used in the equipment of the day. So we spent a lot of time making sure that we could use automated equipment to improve throughput and improve quality. You can see a photo of our roof panel that has dense packed fiberglass blown into it using automated equipment. But because we're pre-installing, that means that we have to worry about just because it looks good in the factory doesn't mean it's going to look good when it gets to the job site. So we performed shaker table testing of panels to prove that there wouldn't be road settlement. Interestingly, there aren't really standards for how to do this, so we had to adopt from other industries. So this is ISTA 3B testing, we're doing drop testing, we're doing shaker table to represent about 750 miles of road transport. But I'll highlight probably one of the scariest days of my life that I can think of. This was when we unearthed that first panel that you see right there. That was the first bundle I ever built in a factory, sent to a job site, and uncovered it. There's a lot of potholes between New Hampshire and Connecticut in January. So I was, you know, you put it on a table and you shake it for an hour or whatever. What does that mean, right? Well, ultimately the insulation didn't settle and I kept my job, right? So that was a good day. We also have been implementing finishes in the factory and then trialing those things. The system was ultimately designed to be finish to finish, and we'll talk about that more in a little bit. But you can see some photos of materials getting figured out in the factory and then ultimately trialed on the job site in one of our homes. So that first project that we talked about, we built the panels in 1 week. That is actually the same panel that you saw that I was very happy to see on the job site, but just in the factory. And this small ADU in a backyard in Mystic, Connecticut was raised in about 3 days. Now that's honestly a little slow, but it was the first time we'd done it, and we learned a lot from that process. It looks, it's absolutely beautiful. I wish it was my house, to be honest. And the homeowners loved it. They actually loved it so much that they got a vanity license plate of the name of the house. So, diehard fans, right? And shortly after landscaping stuff, it's an absolutely beautiful home, high-performing home, less than 1 ACH 50. It's, they didn't go for net zero certification, but it could have been fully powered by solar. We're not talking about low-quality open panel products. This is a high-quality system that is ultimately delivering really, really beautiful buildings, I think. Second home, we did the panel fabrication in 7 days, but that included some of the finishes, like some of the siding that you saw, as well as some interior finishes. This home was raised in a single day. It was a long day, but it was a single day. And I don't know if everybody knows the term ACH 50, but air changes per hour at 50 pascals. Effectively, it's a test of how airtight a building envelope is. You pressurize the home to 50 pascals of pressure, measure the air changes per hour. Code would be somewhere around 3, 2.5, 4, depending on where you are. This home, after we raised, was 0.26, which is a full order of magnitude more airtight than what code would require, right? So this is an incredibly high-performing envelope that's airtight and ultimately going to be high-performing for a long time. HERS index was 43. It was zero energy ready, EPA Indoor Air Plus, Energy Star rated. Now it's a rental property in Keene, New Hampshire. So those are just the first two, right? And we got to monitor them for, ultimately I think we just finished the 3-year monitoring window that we had, right? So I'm looking forward to get to present that down the line. But you're looking at a little bit of our dashboards that we had, that we were monitoring the houses over the years. looking at what's really cool is because we build the houses in 3D and we know we had to locate them in the model to put them in the factory. I have 3D representations of where every sensor is in that house in a model that I can spin around and look if I see issues. We were looking for things like mold growth, using mold growth modeling, verifying just temperature and relative humidity looked good. Isoplex are when you have relative humidity versus temperature, you can look to see if you're in mold growth regions, tracking indoor air quality as well as energy usage. So it's a little creepy, some of the things you can see when you can tell what they're doing and when they're home and not, but you know, it's fun to get to see the energy usage and prove that the houses are performing the way that we want. So what did we learn? We saw no observed excessive humidity or sustained mold growth was calculated at all. Both homes were net zero capable based on their energy usage. I'm not saying one was net zero ready, but they were both shown to be using less energy than their roofs would allow you to use, right? Or would allow you to get through solar. The second home I thought was really interesting that the energy usage matched the HERS rating prediction to within 1.3%, meaning the ideal model that the HERS rating system was using, the inputs that we had matched. If that, you know what I mean? So what we delivered was what was modeled, I guess is a better way to say that. And we actually diagnosed multiple HVAC issues remotely and were able to solve problems. So when you're building high performance, I find that HVAC contractors aren't always used to dealing with the higher end systems and with very airtight envelopes. So they underventilate, you get worse indoor air quality, and they're just not commissioned correctly, you know, just complete incorrect settings. So, you know, heat pumps are difficult, I guess. But we were able to diagnose those remotely and inform the building owners and have them fix them so it's a better space to live for the occupants. So ultimately, we were A+ in all the metrics, which I was very happy with. But that was, you know, years ago, right? It's been 3 years since we built those houses. What are we up to today? So the thing that I've been spending a lot of my time on recently, and I'm very proud of, is our evaluation report with the ICC. So I think hopefully that QR code works if you guys want to check it out. But this is a evaluation report that shows that we have compliance with the IRC, the IBC, and the IECC as approved by ICCES. So ultimately that means that they are inspecting our manufacturing and QA program. It gets audited by the ICC. This report includes things like structural tables for wind and snow loads. It includes thermal performance of the panel, so we can credit the full performance of the assembly, not just the R value of the insulation within it. And ultimately with that information, you can show IECC compliance much easier, right? So this is effectively a, you would think, oh, this system should be easily adopted everywhere because we're approved by the ICC. It shows we meet IRC, IBC. It's not always the case. Going to each of the individual states, they all have different requirements and different expectations. Some consider us not part of their modular programs because of that open panel, closed panel, quasi-state we live in. And others think that even though we're panelized without electrical or plumbing, that we must go through their modular programs, even though we're a panelized group. Actually, just recently, I don't want to throw any shade at one particular state, so I'll leave them anonymous. But we were discussing with a program recently where we showed them our updated evaluation report from the ICC, and they said, oh great, you guys don't have to go through our system anymore. This is fantastic. Just attach your evaluation report and any details with the permit set that goes to the local, and you guys are all great. And then less than 24 hours later, I got an email back from the guy saying he talked to his boss and we do have to go through the program. So that gives it, and now imagine having discussions like that across, you know, the 20-something states that we're operating in today and the 50 states we're going to be operating in the future. You can imagine the complexities, right? So this tells you what the performance of our assemblies are. We've also just published guidelines that empower customers to design with our system. So if you want to design a house that will be faster to build and more aligned with our method of construction, we tell you what are the maximum panel dimensions you can design with, what are the maximum window to wall ratios, shear strength values, all that stuff. This is also available. So between these two documents, now people can design with One Precision Assemblies in mind, as opposed to always just starting from a house that was designed for on-site construction and having to convert it, right? So this should streamline things quite a bit. So ultimately, we are offering single-family homes, multifamily, townhomes, ADUs, from 2 manufacturing facilities in the US, so we're covering the East Coast very well. And we're offering both fully custom, you come to us with your plans, as well as curated home designs that are designed with our assembly in mind, so that way you can deliver much faster. But, okay, that's me. I'm gonna kick it back over to you guys and you can move on to where we're headed.
Yeah, so I'll be really brief here. Thanks, Will. So much of the technology that you just saw and One Precision Assemblies core is really the core for a roadmap for the company through 2030. You know, we want to take the solutions that you just saw and apply them to a range of opportunities in residential. Certainly that's where OPA most best fits, but the system thinking concept, imagine some of the applicability of some of what Will overviewed for you to non-residential sectors, such as the debate currently around data centers and energy efficiency within them. Infrastructure, you know, a huge part of our business is also in the construction chemical space, which plays into the OPA realm as well, in concrete additives and watertight proofings and things of that sort. So you're going to see a lot more from us in this space, and it's something that we're incredibly excited about to be really approaching from a system solution perspective. So I promise to be brief. That's it. Tyler, back over to you. That's it.
Wow, that was brief.
And I fall.
But we wanted to shave off 17, 18 minutes for some Q&A with this team. I've got a couple of questions prepared, and then we'd like to open it up to the floor for anyone who has questions out there. We'll start off with, I don't know, Dennis, probably you, but all of the team. What has been the most challenging obstacles encountered for a company like Saint-Gobain, who's, just to be clear, a 360-year-old building materials company whose first gig was manufacturing the glass from Versailles for King Louis XIV. So these guys have been around for a very long time. When they do something, and they're in it for the long game. Given that context, what are some of the most challenging obstacles you've encountered trying to launch and scale the One Precision Assemblies housing platform?
So maybe I'll start and just speak to some of the technical challenges in the factory, and then as we started to launch and went on site, and I'll let Dennis maybe speak to the scale side, if that's fair. So to start, like it's maybe obvious after the fact, but all the challenges at first were in the factory. How do we implement our materials? How do we take materials that are not intended to be used in a factory context and get them into forms that make sense for an offsite construction methodology? And a lot of time went into just trials and verifying that we could do what we thought we could do, right? But as we've launched and we've started building many more projects, I find that the challenge is actually coordination and the line between the foundation and our panels. You would be amazed at how many times we show up on a job site and the foundation is out by inches or more, or walls are not parallel, and we've built everything in the factory as designed in the model, and you show up and the coordination just isn't there, right? You're missing hold downs, you're missing straps, you're missing things, and it causes a lot of rework. So you can imagine that would be challenging as you're trying to move and you're trying to grow, and you keep getting pulled back by foundation issues, right? That's one area where we have
some site challenges, setting the panels, communicating through the site-based team.
And you could imagine that, like, if a foundation is wrong in traditional construction, well, they typically just grow the house a little bit, or they shrink the house, or they just make it work, right? But if we're showing up with panels that are built to an 1/8 inch tolerance, and the foundation is out by 3 inches or something, that's a challenge, right? But that's very narrow looking. I'll let Dennis speak to the broader thing.
Yeah, from a scale perspective, I think it's the lack of clarity around the regulatory process. In part specific to what we are. We have this sort of scenario where we show up to a state or to an AHJ, and it's, what are we? Are we open panel? Are we closed panel? Are you modular? Are you even industrialized? Is this more like a truss with some insulation? And so, the first challenge is figuring out where we fit in the regulatory structure on a state-by-state basis. The second is every state has a different process. We do expect, every state should have different building codes. That's normal. Any builder's dealing with that. That's actually kind of the easy stuff. The hard stuff is not even knowing who to send your plans to. And you send them, and maybe 3 weeks later you get a response. Why did you send this to us? Okay. Who should we send them to? We'll send it to the AHJ. Send it to the town, and they say, no, you need to send this to the state fire marshal. Why are they involved? So that happens on certainly on an every state basis, but it is a risk on an every town basis. And how we deal with that is we get ahead of it well in advance. And it's expensive to be doing that, but for us, it's the only way that we can scale is being proactive.
Dennis, for clarity, OPA is available in 20 states currently?
Yeah, so the problem is going to double soon.
Right, because your ambition is national.
Yes.
All 50.
Yeah, and it's not a regional problem. It's again, not to call it any states, but 2 states right next to each other should be very similar, are completely different, even in what they call us, let alone how they regulate us.
Yeah. Which brings us to our next question. I think it's perfectly timed. So, what federal and state government support would most benefit scaling the One Precision Assemblies integrated panelized building system? You guys occupy this space between open panel and closed panel. We've seen all over the world how effective closed panel construction is, and how much penetration it's achieved in the mature markets overseas. Ideally, where would you like to see the One Precision Assemblies panel? Fully enclosed, partially enclosed, some combination thereof?
Yeah, I guess where we'd like to see it is up to the point where it's still bringing value to our customers, who are the builders and developers. So we've, taken a decision that there are certain things that builders and developers make more profit on if they do it themselves. Or there are things that make more sense to be adaptable to a local market, maybe even after the building envelope is built. Kitchens and baths and things like that tend to be very market specific, especially in the the mid range of the market. That being said, there's a lot further that we can go in enhancements, and as Will showed, we initially conceived of this as being siding to drywall, and had developed some new technologies on how to do that, and realized the technology isn't really the problem. The building materials aren't the problem. The problem is, once you start adding services like mechanical, electrical, plumbing into a panel, you open up a whole new can of worms from a regulatory perspective. And in the absence of a way to get a systems approval on the mechanical, electrical, plumbing out of the factory, there's always a risk that panels or modules, if it was modular, show up on site, and the inspector says, I can't see it, I don't know what's on there, rip it out. And at our scale, it's just too risky. So until we're confident that won't happen, we're not going to include the systems and close it up. And then the second piece is there is a kind of a trade question, on-site trade question. So when you do panelized or even modular, you're never going to finish 100% of the electrical, plumbing, HVAC, and drywall. It's just not possible because you have pieces that come together unless it's a mobile, a single wide mobile home. And so the fact that you've done 85, 90, 99% maybe of the scope in the factory, you still need to hire an electrician, a plumber, an HVAC installer, a drywaller to come and do what for them may be a couple hours of work. In the case of the electrician, maybe a day, and they're not going to charge that time. They're going to say, I'm not going to show up on your job site for less than maybe half of what it would normally take to do this job. And so that is a real challenge that will get in the way of us going further with the services and the finishing in the factory.
During your session with Ivan yesterday, you guys discussed housing system certification. If you could just touch on it briefly, how important would a program like that was approved at a state level allow you to function as a company and a manufacturer?
I can take that one. So I think that in a lot of ways, if you missed yesterday's panel, you should go back and watch it because it was great in terms of explaining the nuts and bolts of housing system certification. I think we're really encouraged to see state governments in particular taking a look at permitting, right? If you look at just the legislative pipeline for this year, finally, I think many of us are excited that they're marrying housing proposals with recognition that the permitting is a huge part of the problem and you can't do one or the other. I think at the same time, we'd like to be able to come into those conversations and present this as an example of where, if there was something of, around the schema of a housing system certification, the pathway for this might be so much faster, and therefore the chicken and egg problem of do we deal with housing, do we deal with permitting, what do we need to do, might become a little bit clearer for lawmakers moving forward. So that's something we're excited about participating in that discussion.
I'll just add to it, I think the aim is not to make it easy, the aim is to make it clear.
Yeah, agreed.
It's an important distinction. One more question, and we could open up to anyone in the audience who has a question. Do you, as a team, as a company, consider energy performance and resiliency a strategic market advantage? And if so, how have these system attributes impacted the adoption and reaction to One Precision Assemblies in the marketplace?
Yeah, I'll start there as well and then pass it back to Dennis. I think from a public policy standpoint and from a corporate identity standpoint, listen, we have been super focused on net zero goals for a long time now. And with every product that we do, our R&D teams in Massachusetts, here in the US, are looking at how do we meet and most usually exceed standards that are set, whether that's state or federal. And so it's incredibly important to us, and it's something that I think, regardless of the policy debate out there, our customers have come to expect, because they're either receiving pressure from their customers or the state in which and locality in which they're operating expects and demands that it meet certain thresholds. And we often are the only provider who is offering that as a complete solution to them, which is exciting.
Yeah. I'll just add that, it's an advantage to the extent that our customer, who's the builder or developer, wants to use it as an advantage in the market. So we have some of the builders that we support. They say, well, energy efficiency, yeah, maybe that's the future. We'll see. And then we have others who say, I won't build anything unless it's zero energy ready. Or they come to us and give me passive house level performance, but I just don't want to pay for the passive house certification. So for those folks, obviously, this is a big advantage, and they found a way to either use that as a way to beat their competition or to be more profitable in that market. I think from a resiliency perspective, no one buying a home wants to think that within a few years there's going to be some kind of disaster that will cost them $50K, $100K to repair. And when we see the increase in the storms that are happening throughout the US, I do think that the consumer is becoming more aware of the fact that even building to code isn't enough to prevent not just the financial, but the huge life impact of there's a hurricane, and yes, my insurance company paid to replace my shingles, but are they paying to put me and my family in a hotel for 3 months while I get mold remediation? And who is going to make me feel okay that my children are going to be safe knowing that the whole house was soaked for that amount of time? And so that, I do feel, will be an even larger driver from the market, but it'll have to come from homeowners saying, I want better housing. And then hopefully that will bring a competitive advantage for builders and manufacturers like all of us who are focused on better performance.
Excellent. Anyone in the audience have a question? Oh, a couple. Okay. Maybe we could pass a mic around. We've got a good 70 minutes left, so whoever raised it first is fine. Just throw it in the air.
First of all, thank you very much.
It's not on. There you go.
Thank you guys very much for the presentations. Very good. My name is Haifu. I work for Owens Corning. I'm a mechanical engineering PhD by training. I'm working on new product development here in the company. And on the pain points that you guys mentioned on the panelization using wood product, I assume, you mentioned there are challenges during transportation. What are the challenges? Is weight or nail retention, these are challenges? If it is, what if we have a product there that can overcome these issues? Would that be worth for you guys to consider, maybe consider the ICC ESR update? I know it's a long process and expensive. Is that worth the effort?
Great question.
So I think from a transportation perspective, the challenges are mostly volumetric, not weight, right? So a lot of our system standards are defined to make sure that we can ship panels down the road without needing expensive permits and wide loads, and that they fit on standard trailers, right? But we do have to consider things like lifting loads and shaking and all that kind of stuff as we're sending them. Generally speaking, though, other than for insulation, the existing nail patterns that are there are sufficient to withstand lifting loads, right? It would not be great if I lifted a panel and it couldn't withstand the lifting loads, but it could withstand shear from a windstorm, for example, right? And the ESR, I think, you're absolutely right. It takes a lot of time and effort, but I do think it is worth it. I think it shows the value of the system. Ultimately, I'm hoping streamlines approvals going forward and allows people to work with the system more readily. Right? But I'd love to talk after if you want to chat more. Yeah.
So Will, are you finding that the ICC ESR report is helping you communicate the system at a regulatory level, a customer level, what level? All the above?
It is certainly much easier to go to a local jurisdiction when you have a ESR, and they don't have to worry about whether or not you can build a house in their jurisdiction using your system, right? They just know that the ICC has approved the product, right? Now that doesn't exclude you from a state modular program, for example, but in communicating with AHJs, it's definitely streamlined that process.
It raises the level of confidence in your system.
Yeah. It's just as confident as if you're going to use a hanger on a project. Nobody questions that a hanger is going to meet its loads or that I need to show the calcs for that hanger. People just say, okay, well, the ICC approved it. Well, you can use it on a job site. Right?
Excellent.
Thank you. Fascinating system you're showing here. Will, I noticed, I think it was your second home, the photo showed like the exterior siding on one side, but then the face of the home on the photo, it didn't have it.
Yep.
Could you elaborate a little bit on that? And then also, who's your competition? And that point you brought up about the inspection and having to rip things out, that seems so counterproductive. I mean, wouldn't the inspections occur in your factory, prior to it being released?
So for the siding, that was the photos you saw were the first time we had ever put siding on in the factory and shipped it to the job site. Right? So we didn't want to do the whole house to find out we had a problem and then have to rip the entire house down, right? So we focused on 2 panels to try to not slow down the manufacturing process, right? But since then, we've provided homes with all of the siding, or as much as, I should say, as much as the siding as the design will allow, right? There's certain areas that you have to finish on site. But Dennis, do you want to speak to competition maybe a little bit?
Sure. I mean, this is it's going to sound like a cop-out answer, but I think the competition is the entrenched sense of let's not change something because I'm afraid. I don't see modular as competition, not because I don't think modular is great. I don't see other panelized as competition. I see what we're all fighting with fighting against as innovators in the building industry is how do we get people to be willing to try something different and rethink a bit the way that they consider the economics of building. And because there are a lot of customers that a lot of builders that we work with, they say, look, if I'm lucky, I have 10% margin on a project. If one thing goes wrong, I could be 10% under. And if that happens, I can't make payroll, if it's a smaller builder. What we feel is important to look at is not how do you protect that 10%, but how do you move that to something closer to 20, 25%. And are you willing to take the chance on something new? And one of the advantages that we have is we can say, we'll make it right for you. If we're wrong, we'll make it right. But not a lot of the industry is able to do that, and so there's been a lot of hesitation around trying something different, whether it's modular, panelized, or I'm sure sometime way in the past people were afraid of trusses as well.
We're actually out of time. We're only competing with lunch, which the One Precision Assemblies team is certainly available for some Q&A and follow-up. Please do reach out to them. They're open to that. I'd like to thank Dennis, Will, and Matt for their time and participating. A round of applause. And thank you for your attention. There's a QR code for additional information for the system, so feel free to jump in on that. Thanks, guys.